Hello, this is Chitran from Just Tutors. Today in this video we are going to learn about force and laws of motion. Objectives of this video are momentum, second law of motion, some real life examples of second law of motion, and then some numerical based on second law of motion. As in last video we have learned about first law of motion. Let's move ahead. Here we go. First of all, we have momentum. So it is the power of motion an object. Momentum has both magnitude and direction. So, mathematically, momentum of an object can be defined as the product of mass and velocity of an object. So, we use small p for momentum, m is for mass of an object, and the velocity is represented as small v. The SI unit of momentum is kilogram meter per second. We also write it as kilogram meter in seconds power minus 1. It represents per second. Its direction is same as velocity of the object. We can also say momentum is directly proportional to the mass and velocity. It increases with the increase of either mass or velocity of an object. Hence, a lighter and a heavier object is Hence, if a lighter and a heavier object is moving with same velocity, then heavier object will have more momentum comparatively to the lighter object. Similarly, if a small object is moving with great velocity, it has tremendous momentum which can be fatal. For example, a small bullet having a small mass can kill a person if it is fired from a gun. Now here comes Newton's second law of motion. So the first law of motion indicates that when an unbalanced external force acts on an object, its velocity changes. That is, the object is accelerated. Now let's study how the acceleration of an object depends on the force applied. Consider the example: a car at the rest does not require much attention when parked along a roadside, but the moving car, even at a low speed, may kill a person standing in its path. A small mass, such as a bullet, may kill a person when fired from a gun, as this example we have discussed on last slide as well. From these examples, it is clear that the impact produced by the objects depends on their mass and velocity. When we combine the mass and velocity of an object, we get another quantity called momentum, which was introduced by Newton. So the second law of Newton says the rate of change of momentum is directly proportional to the applied unbalanced force. It happens in the direction of applied force, as you can see in this picture. Let's take an example. When acceleration is applied on a moving vehicle, the momentum of the vehicle increases, and the increase is in the direction of the force applied, in the direction of motion. On the other hand, if brake is applied on the moving vehicle, the momentum of the vehicle decreases and it is in the opposite direction of motion because the force is being applied in the opposite direction of motion. Now, how can we formulate this second law of motion? So we have a mathematical way. Let's say there is an object which has a mass of m. So let's say this is an object which has mass m. U and v be the initial and final velocity of this object when momentum changes in the time interval t. Therefore, from the momentum or the formula of momentum, which is p is equal to mass into velocity, so we can say initial momentum of the object is p1, which is mu, because the mass will remain the same for initial and final velocity, and we have u as initial velocity, and the final momentum of the object similarly be p2 equals mv. According to the second law of motion, force is directly proportional to the rate of change of momentum. So we can write it like this: force is proportional, or we can say directly proportional to rate change of momentum. Further, change in momentum can be worked out like mv minus mu. So rate of change in momentum is, rate is like that in how much time it is changing. So it is changing in t seconds, so we'll work out like mv minus mu upon or divided by t. So force is directly proportional to mv minus mu upon t. So here we get it like this. Since acceleration is the rate of change of velocity, so we can write it like a is equal to v minus u over t. Here you can see we have taken m as common and it will become m into v minus u upon t. So this whole quantity can be written as a small a. So we can write it F, that is force, is proportional to ma, which you can see on the next slide here. Now in order to remove this proportionality sign, we use a constant which is k, and we call it proportionality constant, and here k is equal to 1. So by this we get force is equal to mass into acceleration. So here we get a formula for us, F is equal to ma. You can see here as well. So from the above relation, it is clear that acceleration increases with increase in force and decreases with increase in mass, and vice versa. That is why a small vehicle requires less force to attain more acceleration than a heavy vehicle. Now here are some applications of second law of motion in daily life. First is long jump. After performing a long jump, when an athlete falls on the ground, the momentum because of the velocity and mass of the athlete is reduced to zero. If the momentum of an athlete will be reduced to zero instantly, the force because of momentum may hurt the player. By providing a cushioned pad in form of sandpit, the time in which the momentum is reduced to zero of the athlete is delayed. This prevents the athlete from getting hurt. We can also use or discuss an example in our cars. We use seat belts in cars. So, seat belts in the vehicles resist the passenger from getting thrown in the direction of motion. If there is an emergency like accidents or sudden braking, passengers may be thrown in the direction of motion of vehicle and may get severe injuries. The stretchable seat belts increase the time of the rate of momentum to be reduced to zero. This delay in reduction of momentum to the zero prevents the passengers from severe injuries. Here's a numerical problem. We can try one here. Let's say the question is, calculate the force required to accelerate a car with a rate of momentum 6 meter with a rate of 6 meters per second square. This is acceleration as accelerated if the mass of the car is 500 kg. So we need to work out the force. So according to question, we have acceleration A is 6 meters per second square, mass of the car is 500 kg. We need to find force. We know the formula, that is F is equal to m into A. So we'll work out 500 kilograms into 6 meters per second square will give us 3000 kilograms meter per second. Therefore the force will be 3000 Newton. Here's another example. You can try this example by pausing the video. Now we have some practice questions. Again, for trying these questions, you can pause the video and check your answers on the next slide. That's all for this video. For more videos, you could log on to justtutors.com. Thank you.